Hello everyone, welcome back to the Let's Dream Civils YouTube channel. Today we are going to discuss about a very interesting development in astronomy using the James Webb Space Telescope. The James Webb Space Telescope captures weather on exoplanet. For UPSC, this topic connects with space technology, astronomy, exoplanets, and the capabilities of modern space telescopes. What is the news context? NASA's James Webb Space Telescope mapped dynamic weather patterns on exoplanet WASP 94AB. An exoplanet means a planet which exists outside our solar system. What is the James Webb Space Telescope? It is a spacecraft telescope designed to detect the most distant and coldest objects in the universe. It will also analyze faraway, potentially habitable planets and other cosmic events. The James Webb Space Telescope is the successor of the Hubble Space Telescope. The WASP 94AB, the exoplanet that we are talking about, is located approximately 690 light years from Earth in our galaxy. 1 light year means distance traveled by light in 1 year. So 690 light years means the light we are observing from this exoplanet has traveled for roughly 690 years to reach us. This telescope has discovered that there is an atmospheric asymmetry in WASP 94AB. In this statement, you could see that WASP 94AB shows a cloudy, cooler morning limb and a hotter, clearer evening limb. Here, limb means the outer edge of the planet which is visible in space. Morning limb is the edge turning from night side to day side as the planet rotates, whereas the evening limb is the edge rotating from day side into the night side. The morning side of the atmosphere is cooler and cloudier, whereas evening side is hotter and clearer. This temperature difference drives atmospheric circulation and contributes to the formation and evaporation of mineral clouds. Now let us understand what kind of planet WASP 94A is. It is classified as hot Jupiter. Why? Because it is a gas giant exoplanet orbiting extremely close to its host star, resulting in a very short orbital period. Due to its closeness to the star in distance, it receives intense stellar radiation. Therefore, it has high atmospheric temperature. The planet is also very large compared with Jupiter. That is approximately it is 1.6 times Jupiter's radius, but only half its mass. So it has relatively low density atmosphere and can be described as a puffy or inflated gas giant. Ultra short orbit. The exoplanet WASP 94AB completes one full revolution around its star in just 4 Earth days due to extreme proximity, means extreme closeness. Now let us understand the extreme thermal environment. It is tidally locked. What is tidal locking? Suppose imagine a planet rotates around its own axis and also revolves around the star at the same time. But if the time taken for one rotation is equal to the time taken for one revolution, then the same side of the planet always faces the star. This is the exact scenario that is happening with WASP 94AB. Since it is gravitationally bound, the same side always faces the star, resulting in permanent day versus permanent night. We saw this exoplanet takes 4 days to revolve around its host, right? And the rotation and orbital period is synchronized, which means rotation also takes 4 days for WASP 94AB. Since there is permanent day side and night side, we can see huge temperature disparity here. The day side of the planet receives intense stellar irradiation, producing temperatures high enough for minerals to exist in vapor or condensate form. While the day side is intensely hot, night side is substantially cooler, producing strong atmospheric circulation driving supersonic winds. Whenever there is a strong temperature gradient, strong temperature difference, there will be strong atmospheric circulation. In simple words, the atmosphere is constantly trying to redistribute the energy from hotter region towards the cooler region. Now we have come to the most fascinating part. Mineral clouds and the dynamic winds of this exoplanet creates the planet's weather cycle. Cooler mornings. Air flowing from night side condenses mineral vapors, which consists of magnesium silicate and iron clouds, mineral aerosols, into high altitude rock clouds. Clear evenings. As winds carry the clouds towards the scorching day side, extreme heat evaporates the rock particles, leaving clear evening skies. And then comes the powerful atmospheric wind jet streams. Strong atmospheric jet streams transport the aerosol particles continuously across the planetary terminator. Planetary terminator means the boundary between the illuminated and the dark side of the celestial body. Here they are explaining that due to strong atmospheric circulation, the strong stream of winds transport the heat and atmospheric particles from one region to another region of the planet. So these winds are the essential part of the mechanism that creates the observed atmospheric asymmetry. How James Webb Space Telescope observes the atmosphere of a planet which is hundreds of light years away from us. First one is the transit method. When the exoplanet passes directly in front of its parent star from Earth's line of sight, that is from our point of view, the scientists will measure the small decrease in the brightness of the star. Okay. Then the next method is transmission spectroscopy. During transit, the starlight filters through the planet's atmosphere. The atmospheric gases absorb specific wavelengths, creating unique chemical spectral fingerprints. For example, one molecule of a mineral may absorb light strongly at a certain wavelength, while the another molecule of another mineral absorbs the different wavelength. So, this phenomenon acts like a chemical fingerprint with which the scientists can infer the presence of the minerals and other molecules. The limb differentiation. So we all know from the previous slide that WASP 94AB has cooler morning limb and hotter evening limb, which creates a 280 plus Kelvin thermal difference between the the day side and the evening side of the planet. The key detection metrics. The statistical confidence of the findings. What is the statistical confidence? How do we measure it? We measure it using sigma. So, in simple words, higher the sigma, stronger the evidence that the observed result is real and not a random fluke. Okay. Now, let's see the key detection metrics. First is 11 sigma confidence for what? Statistical proof of thermal difference between cloudy morning and clearer evening limbs. 10 sigma detection of high precision water vapor spectral signature confirmed on the clear evening side. 6 sigma asymmetry, clear evidence that clouds are dynamic condensate cycles rather than the uniform photochemical hazes. Now let's see the UPSC prelim practice question. The first question is, consider the following statement regarding planet WASP 94AB. Option 1, it is a terrestrial exoplanet located in the habitable zone. 2, it exhibits a daily cloud cycle composed of magnesium silicate and iron. 3, it is tidally locked to its parent star. Which of the statements given above are correct? 2 and 3 only, because the WASP 94AB is not a terrestrial exoplanet, it is a gas giant, it is not terrestrial. And then transmission spectroscopy in astronomy is primarily used for analyzing the starlight passing through a exoplanet's atmosphere so that we can determine its chemical composition and the weather patterns. Thank you so much for watching this video. If you find this video helpful, kindly subscribe to the channel and we will meet in the next video. Thank you. Stay tuned.